Over the past few years in Canada, water is often at the center of major headlines. We've seen atmospheric rivers and washed out highways in British Columbia, infrastructure that's built for an earlier era and overwhelmed by sudden downpours in Toronto. Prairie communities wrestle with drought and aging drinking water infrastructure. At the same time, conversations about climate change, resiliency, and how we plan for an uncertain future have moved from academic journals and into water cooler conversations. What's striking is that none of this is abstract anymore. These aren't hypothetical risks or distant projections. They're lived experiences. Roads close and farms flood, basements fill with water, supply chains break, and suddenly decisions made decades ago about where we build, where we live, how we manage water, and what risks we're willing to accept have become very real very quickly. My guest today has spent nearly 4 decades as a water resources engineer, working across Canada on problems that most of us only notice when something goes wrong. Flooding, drought, infrastructure failure, and the complex systems that connect climate, communities, and the natural environment. His career spans not only a shift from drafting tables to digital models, but also changes in climate-informed forecasting and in looking for solutions that consider social, environmental, and economic outcomes together. What makes John's perspective especially valuable right now is timing. As Canada grapples with how to react and adapt to a changing climate, his story offers insight into how preparation, curiosity, and long-term thinking shape both careers and communities. In this episode of AE Live, we talk about career paths that aren't linear, how engineering, education, and technology have evolved, why professional service and mentorship matter, and how water, something so basic we often take it for granted, may be one of the defining challenges of our time. Joining me today is John van der Eerden. John is currently Vice President, Water Resources at Associated Engineering, as well as the National President of the Canadian Water Resources Association.
Coming to you on computer audio, STEM colleagues know ways where you gotta go in your car listening to the Graham and Michael show. It's a whole new interview, bro. Treat your ears, get the gist of careers from the list of our engineers and scientists, and maybe twist it up with technologists. It's a podcast, baby, and not to be missed. Got more fly than a ripe banana, like a salmon got the stamina streaming across Canada. Like a trade sugar banner got the swiggity swag, yeah, and the inside scoop from my host tonight.
Hey, live. You know we're going to innovate. Hey, live. Going to entertain and educate. Hey, live. Got a topic here to elevate. Hey, live.
Thanks for joining me today, John. So you joined Associated Engineering in 1987 with a bachelor's in engineering from UBC. Can you tell me a bit about your time at university and getting started in your career?
Yeah, sure. That's right. It was 1987, and I suppose because I was in university, I didn't think too much about the economic situation until my latter years. But if you look back into the mid-1980s, there was a pretty serious recession going on. And I think a lot of people in the years ahead of me that were graduating were probably having a tough time finding employment in engineering. So that I was sort of lucky with the timing because graduating in 1987 sort of coincided with when the market just started to open up a bit again, and there were some opportunities. But back at that time, I actually started my university, my time at university in 1982, because at that time it was a 5-year program for engineering. And that's because you had to take 1 year of sciences first. And I always found my career progression kind of challenging in a way because I really was unconvinced what I wanted to do in my future. And so when I went back to university, because I had taken a couple gap years, when I went back, it was really a choice that you had to take 1 year, or you had to take arts or sciences, and that was really the only choice. And so that was a relatively easy choice for me. It wasn't a slam dunk, but a relatively easy choice that I would take the sciences over arts, because most of the careers I thought I might go into were on that side of the equation. But after you finish 1 year of science, then you have to decide what if you were going to go into engineering, and if you were going to go into engineering, which discipline it would be. I can't recall how many different disciplines there were at UBC at the time where I was going to school, but I think it was something in the order of about 8 or 9 different disciplines. But the first year it actually was just general engineering. So that wasn't really a choice. I went into general engineering, but after the first year, you did have to decide, or at least put your name forward for your preferred choices. And if your marks were high enough, you got your preferred choice if it wasn't over-prescribed. And if not, you kind of got your second choice or third choice. I was fortunate enough that I chose civil, and there was space for me based on my grades. And so that was my first choice. And so I carried through the civil structural program.
Right. Okay. Then just to kind of span the whole of your career in one question, you're approaching the 40th year anniversary coming up in a little while. What changes have you seen, both if in students coming through programs, university, and just on kind of the consulting engineering profession since you've been here?
Yeah, I think there have been significant changes. I'm actually always impressed with how well prepared students are when they come into the workforce. It's hard to know exactly what's happening with the program and whether the curriculums are keeping pace with the rapid changes in technology, things like GIS, for example. And I know there was a period of time where GIS didn't seem to be taught in the undergraduate program at many of the schools in Canada. And I always thought that was a little bit of kind of a slow response from the universities for that one particular technology, because it's quite applicable across a range of various disciplines. But other than that, I think that by and large, students entering the workforce and that we interview seem to be quite well prepared. Something I think that has been helpful for those that have taken co-op programs, that seems to give students quite a good grounding or understanding of what the workforce is going to be like when they come in and talk to us and interview with us and enter the workforce. But some of the more recent changes, automation, programming, AI, these are areas where I'm not sure whether students are being taught this in the academic institutions, whether they're self-teaching themselves because of the obvious value of some of those tools in the work that they're doing, the homework that they're doing, the assignments that they're doing, and their co-op terms. So that I really don't know, but it's something that I think a lot of our younger employees and people we're interviewing seem to come with pretty good skill sets in that regard.
Right. When you think of technology, actually, it's an interesting line to go down. Obviously, there's technology you're watching emerge today, but from when you started to now, especially in your specific area of engineering and water resources, is there a technology that you've taken advantage of over the course of your career that just was such a changing dynamic for what you did in your practice?
Yeah, I think so. Like 40 years is a long time. So I think the changes that I have seen are very significant. Just going back to what the world looked like at the time I started my career in 1987, there were virtually no computers in the office. Fax machines were very common.
Right.
We actually, in our entire office, we had 2 computers. One of those computers, the better of the 2, was sort of prioritized for our accounting department, accounts payable and what have you, which was clearly a priority. And then the other slower computer was shared amongst the engineers, a few engineers. So that really shows how quickly 40 years is a long time. So I don't know if that's really that quickly, but it's amazing over a career how much things change between then and now. When I did go back, after being in the workforce for around 5 years. It was 1993, 1994. I went back and did my master's degree. And that was about the first time that I was introduced to email. So it's just the initial emergence of the internet, using emails, sort of dial-up access to the internet. And so obviously that was a very significant change, and things progressed quite rapidly after that. The manual drafting tables were disappearing or disappeared quite quickly. Many of the engineers in the office were given the opportunity to take AutoCAD courses and learn how to draft using CAD, which obviously later evolved into Civil 3D and other technologies and just digital technologies in general. But it was in the late 90s too that GIS really became a predominant tool in the industry. And I recall at that time really encouraging staff, people that I worked with, people that were starting to report to me around that time that we should improve our skills with that particular technology.
Right. Makes sense. Yeah. And it keeps evolving in the importance of people learning the new technologies as they emerge. You've talked a lot about how your career has kind of, how it's gone and the idea of being in the right place at the right time. In looking back, what are kind of the key moments that you look back on that have taken you to where you are today?
Yeah, that's interesting because, when you think about a career progression and a path, I never really had a strong objective where I thought I was going to end up, what I thought the ultimate goal was. What I really did is I think I generally took a shorter sort of view or perspective on my career path, always thinking that if I prepared myself with the tools, if I prepared myself for success in various ways, so that means, continuing to learn, looking for technologies that might be valuable within career progression and things like that. I thought if I could always sort of prepare myself in a way that when the opportunities did arise, I'd be prepared for them. And, looking back, I think my career did progress in a fairly linear path, but it definitely did not feel like that. It felt like each step along the way, I was given choices, and I think I made the right choices along the way, and ultimately kind of ended up where I think I should be, which when I look back on it, just my heritage, having, Dutch heritage. And one day it just dawned on me that I'm a water resource engineer. I'm dealing with diking and flood control and water management and all the things that sort of would be very connected to my heritage. But that was really unplanned because when I started with Associated Engineering, I was hired in the transportation group. That was the opportunity. I worked in transportation. I learned about vertical curves and horizontal and spiral curves and how to design highways. And, those little pieces of information serve you well later on, when we're looking at bridge structures for highways or culverts or different things, and be able to speak the language of the transportation and highways engineers with hydraulic structures for highways. That's a sort of a value-added component that not every water resources engineer is going to know. So I think gathering up those pieces of information as you go and using them to advance your career in different ways is really valuable. There's been so many different aspects that I think have been valuable along the way. One that I would highlight, I already mentioned going back and doing my master's in water resources. So that obviously was an important sort of piece of background that I had in my career. But the other thing was, even before I went back to do my master's, I was solidifying my career in water resources. And I got involved with the Canadian Society for Hydrological Sciences, which is a not-for-profit organization. And they were organizing sort of lunchtime presentations and things like that at that time at an old BC Hydro building in downtown Vancouver. And the community started coming together under that with those presentations and those sort of lunch and learn opportunities. That evolved. The CSHS ultimately became a subcommittee of the Canadian Water Resources Association. And I stayed involved with that association through my entire career. At the provincial branch, I served in virtually every role as a volunteer, becoming the president of the BC branch at some point. And then I moved on to the national organization. And I've been with the national organization for a long time, and I'm the current national president of CWRA. But that involvement, as it has evolved, has really connected me to the industry. It's helped me sort of understand the landscape. Who are potential partners, who are some of the firms that we compete against, and those individuals, who are the clients that participate in these things, who are the academics that support water resources and water resource management. And I wouldn't know so much of that if I wasn't involved in this type of organization. So it really connects you in a very positive way and helps your career develop. So those are a few key items along the way. It's really supported my career progression.
Right. Yeah, I'm glad you mentioned kind of all that time you've given back to the CWRA and other groups. In addition to obviously how it's benefited your career, was there any particular motivation to want to give so much of your time back to professional organizations and contribute that way?
I think so. I think with so many organizations like that, not-for-profit organizations, and getting involved in just various types of professional organizations and or community organizations, I think you get out of them what you put into them. And first of all, quite often when you volunteer and put your hand up to these organizations, there's usually lots of opportunities, and it can draw you in quite quickly. And sometimes you have to manage your own involvement to make sure that it it's not overwhelming, or has a reasonable balance with your sort of that work-life balance and the other things you do. But having said that, getting involved in these different activities introduce you to things that you might not otherwise ever be exposed to, or maybe it just takes a long time to be exposed to them. And once again, that's sort of this incremental type of learning that you get from that type of volunteerism, serving on boards and understanding sort of the relationships and how boards and the membership of these types of communities of practice work, understanding how to organize conferences and seminars and connect into industry and just coordinate efforts across various, the institutions and different people in different practices, or still within the same discipline, but maybe working in different environments.
Sure. Did you imagine as a student how much of your time would be spent on the more relationship aspects of your job?
No, I really didn't. And I guess that comes with time in a way, because as you start off as a junior engineer, you are generally fairly task oriented. Somebody's asking you to complete a task, and you're sort of, completing that particular item and then delivering that, and you move on to the next thing. But as your career progresses, you have more and more autonomy and more decision making and more sort of interaction with others. First of all, sort of internal clients, dealing with the people within your group or the organizational structure. But as you progress from, a junior engineer to a project engineer to a project manager, you start that world starts to open up, because as a project manager, you're not only working with and answering to people within the organization, but it starts becoming much more externally focused, where you're dealing with clients and the public and what have you. And then as you get onto a group manager, division manager type of role, that zone of influence and that communication becomes broader and broader, and it becomes it still remains technical, or it can still remain very technical, but there's so many more aspects to it, dealing with interactions with clients, with staff, looking ahead to bring work into the organization, delivering on those projects. And it becomes very dynamic in terms of the type of work you're doing. But now in my current role as a vice president for Associated Engineering and Water Resources, that's a whole other sort of consideration of those interactions. And we can talk a bit about that if you want.
Absolutely. I'd be really interested to kind of dive into the work you've done. And I guess you started out being, getting out and doing the job, and now you're managing and supporting teams across the company. So are there memorable projects, and kind of how have you enjoyed all the time you spent doing that?
Yeah. Well, first of all, I should describe just the role a little bit and then circle back to the projects. But the role that I have as a vice president it's a national role, or it's across the organization. And I work with our various water resources groups in each of our offices. But the interesting thing about the role of a vice president is that you're really in a position of influence, that people are not reporting directly to you, and they're not delivering work necessarily under your direction. So you're typically not a project manager. So you really have an opportunity for supporting teams, for providing technical advice, for guiding them, but it's really a position of influence rather than a position of authority. And that's very different from a management track where you might be, say, a division manager or a general manager, or the president of the company. Those all tend to be positions of authority where people are reporting to you. You're giving them direction, and they're responding to that direction. Whereas a vice president is very different. You're looking at for strategic opportunities, relationship building, working with a broad range of potential clients and industry to really advance the success of the company. And that's really how I look at it. Every day I come to work and I think, what is that next thing I can do to help grow the company, to help the company succeed? And that's really the mindset of a vice president. But it's taking me into some really interesting opportunities and projects. Recent projects include supporting some large-scale irrigation projects across the Canadian prairies. So that's looking at opportunities for managing water. That's really a limited resource, but looking at how much water can be withdrawn from particular rivers, still without having significant negative impacts on others, and then using that water to the benefit of the agricultural community to look at the potential for irrigating large tracts of land that are currently not irrigated. And so that really can improve the value of crop production and the types of crops that can be grown, and the reliability of the sprinkling, so that you don't have crop failures and you're not reliant on Mother Nature necessarily. Yeah. So, but a project like that is really interesting because you're looking at, first of all, from the source water intake, you're looking at how much water is available, what impacts might you have on others downstream, and that can include environmental values, navigation, recreation, hydropower, flood control, water supply for others like municipalities that are located downstream, for example. So that's just at the intake. And then as you bring that water inland for the irrigation projects, you have to be able to manage that water. So it's often storage reservoirs need large excavations and or dams. They usually have to be repumped or gravity fed out of those facilities. And then you have an entire distribution system to get water to the agricultural producers' properties. And And some of these projects that are being looked at right now are very large in scale. So that's one interesting project. There are a number of others. If you want to hear one or two more.
I would absolutely, but you made me just wonder, in asking that, have you had to deal with projects like that have also then spanned national borders? And I think of locally in the Fraser Valley with some of the flooding and the issues that they're having to deal with, who's taking the water and whose responsibility the flood control is when it crosses the Canadian and U.S. border.
Yeah. So often projects like that, they're dealt with at a provincial or state level, but they can become, or there's an organization called the International Joint Commission, and the IJC looks at these transboundary water issues, things like the Columbia River Treaty. There's a Great Lakes, I think it's Great Lakes Partnership Agreement or something. I might have that acronym wrong, but
Sure.
And then things like flooding from the Nooksack River in Washington State. And a lot of these all sort of, so the Nooksack River in Washington State, when it floods, the water flows north into the Sumas Prairie and can flood can flood areas in the Sumas Prairie, which is what happened in the atmospheric rivers in 2021. So yeah, issues like that we look at, we get involved in different ways. During 2021, during the atmospheric river events, I was brought into the Emergency Management Center, or the Emergency Operations Center. It was located in Surrey. So working with the province to look at emergency response and how to deal with some of these issues. And that included looking at the Nooksack River, the potential for overflows, and what sort of actions might be taken to protect the lands in Canada. And that one aspect of that, it was predicted that the water levels were going to come up high enough that it was going to flood over Highway 1 and flood the Sumas Prairie a second time. And so flood barriers were put across Highway 1, and the Highway 1 was shut down in Abbotsford to try to prevent that from happening. So yeah, we do look at those sorts of issues and the international challenges that occur in some of these areas.
Right. Okay. Yeah. And you mentioned other projects that have kind of captured your interest over the years. Yeah, please do.
Yeah, a wide range of projects. I'll mention one in Ontario, in Toronto. We did quite a large study looking at basement. It's called the Toronto Basement Flooding Protection Program, and that was a result of significant flooding they had in Toronto, and as a result of so many flooded basements. So this is basically storm sewers and sanitary collection system backing up into basements and causing flooding through many, many homes. And so Toronto introduced this program to model the entire city to try to understand the likelihood of occurrence, the mechanisms why they are flooding, mitigation strategies to prevent it from happening, and then implementation of those sorts of strategies. So that was at an urban drainage level, very interesting project. I bring that one up because I think in water resources, it's very interesting that we deal with projects at so many different scales. So that one would be referred to as urban drainage, looking at storm sewer networks and combined systems and sanitary systems and infiltration inflows issues in sanitary systems. The other one I mentioned, the irrigation project. So that's really on the irrigation and drainage side of things. Another major area is hydrotechnical type of projects. So we recently completed a flood hazard assessment looking at floodplain map or developing floodplain mapping for the Nechako and Upper Fraser rivers in BC. And that one was very interesting because I guess at its core, you first have to try to determine what sort of flow rates might happen on these rivers. But we look at the historical record to predict historical flows. but historical flows really aren't a very good indication of what might happen in the future with non-stationarity issues around, climate change, but also forest fires, infestations, development, land use activities. So future flows can change dramatically. So we also looked at sort of future climate change informed hydrology throughout the watersheds to come up with predicted future peak flows. And then there's a very large reservoir at the headwaters of the Nechako River called the Nechako Reservoir. And we had to look at, what happens with flow regulation? What could happen to change the flow rates on the Nechako River? And so knowing those different flow rates for different annual exceedance probabilities, what is the likelihood of flooding, and then developing mapping to try to inform communities as to what the flood hazards are. And based on that, they can make land use decisions going forward.
I'm assuming you've seen quite a change in kind of that perception of flooding and the risks of flooding, for instance, is one part of it. You mentioned climate change, and when you started your career, I don't think those words came out of a lot of people's mouth. How has that changed over the last few decades as people become more aware of the changes that are happening?
Yeah, it's an interesting question because I have trouble putting my finger on exactly when I first heard about climate change. And I think, probably at, maybe it was around the turn of the century or so, maybe a little bit earlier. But if I'm really honest with myself, I probably, think initially when I heard about it, there's probably a little bit of skepticism. But then the more you study it, the more you learn about it, the more you sort of see the trends and understand that a lot of the, let's say, people that don't sort of believe or are a little more hesitant to understand climate change, they're often talking about the signals or the chatter in the results rather than looking at the trends that you see when you look at model ensembles and looking at potential changes. But I find it quite interesting because I think the modeling has improved. It continues to improve. The approaches and the understanding and the knowledge is definitely improving, but maybe what's becoming more uncertain is the future emission scenarios and what society is going to, how we're going to respond to it in the future with all of the geopolitical issues happening right now. The headlines drill baby drill. We did have carbon pricing on fuel until recently, and then there were EV incentives that we still have to some degree, but they're being scaled back. And so a lot of the positive momentum, the pendulum maybe, or maybe the pressure is coming off a little bit, but that doesn't mean that climate change is going away. And so I think we're going to, a reckoning will come.
Right.
And,
in talking to some of our environmental scientists and their perspective on climate change, I think one of the key things that came out that maybe was interesting in one of our podcasts was that the severity of something might not be the issue. We've had major floods over the last few hundred years. It happens. We've had major environmental disasters. It happens. But what used to be 1 in 100 or 1 in 200 years is now becoming a 1 in 20 year event. And that changes how you prepare for things. What kind of things have you had to do in the more recent projects you worked on, and where do you see the next 5-10 years in the water resources area changing and evolving?
Yeah, it's interesting because it's really not one size fits all. I think you really have to look at the specific circumstance and really try to understand what the potential impacts might be. When you look and this is in different regions, different geographies, and combinations of different events. So, for example, if we look at an urban environment where with global warming, the atmosphere can hold more water vapor. That water vapor can come down more rapidly. So in an urban environment, we might see, or we can predict that in most areas of Canada, there will be a fairly significant increase in that short duration, high intensity rainfall that will cause increased urban flooding. That's not necessarily the case on all rivers, for example, because what we see in some cases is that the predicted peak flow on some rivers might, and these are generally freshet dominated, let's call them watersheds with higher elevation headwaters. In some cases, these watersheds show an increase in predicted peak flow going into, towards the middle of the century and maybe even the third quarter of the century. But in some cases, it tends to drop off afterwards. So we go through this time of worst case, highest risk, highest predicted flood flows that might not persist, and they might actually become less with time. And the reason for that is because a lot of that snow accumulation, snowpack accumulation, that if you have a rapid spring warming, you can have a large snowpack that melts quite quickly. The peak of that runoff might be a little bit earlier in the year, but it might cause quite a rapid runoff event and a high peak flow. But as we go further on towards the end of the century, that snowpack might not accumulate to the same degree because we have more midwinter rainfall and possibly smaller accumulations of snow. So that source snow, the freshet impact might be lessened. And that's why you really have to look at the particular circumstance and situation. But I find it very fascinating because there's significant complexity to all of these systems, because sometimes these events combine in different ways that did not happen before. So although you might look at one item individually, like what I just described with a potential reduction in peak flow from freshet into the future for some watersheds, it could be that now you might have the two systems that otherwise their peak flows did not coincide. And because of that changing mechanism, the peak flows now might coincide. So there's sort of this compound effect of potential flooding. And there's many ways that can happen. It can happen because of urban flooding combining with high river flows or storm surge on the ocean, ice melt, and so many circumstances. I think you have to start from looking at all of the potential outcomes and then looking at them individually and then combined to try to figure out the critical cases.
You make it sound complicated for the average person. So, do you enjoy kind of diving into that part of the work? Is that for you? What's driving you these days?
I think so. I think it's really important to ask all of the questions, and sometimes turning over all of the stones and saying, wow, we might have missed that one, or did we look at that? And I think sometimes, the big events, natural disasters and things often end up being kind of a combination of things. You look at it and say, it wouldn't have happened with that because of that one thing alone.
Right.
But when you put two or three things together, and all of a sudden you realize, oh, that's why this big event happened. And I think that happens a lot in water resources when you start looking at the combined probability of different events occurring and that happen to combine.
Right. Okay. In the vein of finding solutions for things, we look at some of the protections that were put in place for flooding traditionally, concrete or building up rock walls or whatever it might have been. I know some of our environmental staff have talked to me about bioengineering and looking for natural quote unquote solutions to flooding protection. Has that been an impact in your career, and what kind of developments and what have you seen in that area of things?
Yeah, I think that's evolved in a very positive way, actually, over my career. When I did, when I started out, the standards associated with so much infrastructure, it was very hard engineering. It was very black and white. It was in a lot of ways, design standards were dictated through these standards. And I think the industry, we really see, I'll call it a softening of those approaches, where there's more green infrastructure with a broad range of considerations around, the social, the environmental, and the economic values of solutions. And so there's really a moving away from, let's say, gray infrastructure towards green infrastructure. And in the context of, say, rivers, that means more looking for setback flood barrier alignments. It still might be a berm, it still might be a flood wall, but it could be a whole variety of structural and or non-structural approaches. And non-structural approaches, there's a term called room for the river that I think was coined in the Netherlands, or a translation thereof. And it's basically just, recognizing that the river, when it goes into flood stage, it needs that space of the floodway and the overbank floodplain areas for the conveyance of flows. So rather than prioritizing development near the river, maybe it's a better idea to recognize that happens and then set back infrastructure. And in some cases where there is existing infrastructure, relocate that into a safe location. And it's, if that was done completely, you wouldn't actually need the flood infrastructure, the dikes and the barriers, because you'd have full room for the river, but that's unlikely to be practical. So I think, more often than not, you're sort of looking at what the floodplain area is and then identifying those areas on the fringes that could, or that might be protected, but still making sure that there is substantial overbank areas, that you're not impinging those flows, that there's these infrequently inundated areas that provide so much environmental value in terms of removing pollutants, improving water quality, and providing habitat for various species.
Right. This question is going to be somewhat off topic, but I was reading an article just the other day talking about how some researchers had discovered a lost city in Iraq, Alexandria, which had been built by Alexander the Great as a kind of meeting point of a spot on the river where they could get shipping from Mesopotamia and then deliver it into Greece. And the city disappeared because the natural course of the river changed on them. We wouldn't allow that to happen to rivers these days, but how does that? It just made me wonder, how does that human influence on rivers, and what would the natural progression of watersheds, water flow be if we didn't do what we do to it these days? And
yeah, that's a very interesting question. And, right away, I picture a city like Las Vegas built in the desert, and,
right.
A city that would not exist if not for the Hoover Dam and, the capturing of water to build a city in probably the most unlikely spot on, or one of the most unlikely spots on Earth, and turning it into what it is. But having said that, there is some reversal of some of these engineering infrastructure, dam decommissioning, setting back of dikes, managed retreat of floodplain areas. And, it's done obviously in a managed and careful way, but there is a recognition that some of the practices of the past have not been maybe the best long-term and certainly not sustainable solutions. And so there have been, there is some, there are some projects or some emphasis to undo some of this work of the past.
Right. Maybe let that nature reclaim some of what it would have done. All right.
Mm-hmm. Yeah.
All right. Well, thank you, John, for joining me. My co-host on these podcasts, Michael Tolboom, has been asking his guests for a favorite cocktail or insights into the history of the chimichanga. Let's wrap this one up with one question. And I guess it's, do you have a favorite recipe for either a summer patio cocktail or barbecue season, if you prefer to stay away from the alcohol?
Barbecue season. No, I'll go with the alcohol side of things, but I've just got to say this, that I went through maybe decades with really not being a fan of beer, period. It just wasn't my go-to. So I preferred wine over beer. But I've got to say, over the last 10 years or so, as the craft brewery scene came on, that I really, really, really enjoy a good craft beer. I think, unfortunately, these nice beer didn't exist. Maybe that's why I didn't enjoy it very much. And now we have so much selection. So I'm just going to stick with a really simple answer. It's not exactly a cocktail. But it's a nice locally brewed beer, and that's going to be probably an IPA. And I'll shout out Backcountry in Squamish, BC is one of the best.
All right, that would be your choice for the summer patio.
I think so. Yeah, right. With over the barbecue.
Yeah. All right. Perfect. Thank you for taking the time and chatting with me today. And we'll look forward to putting it out there for you to listen to.
Great. Thank you, Graham. I appreciate it.
That was John van der Eerden, Associated Engineering's Vice President, Water Resources. What stands out to me in this conversation with John isn't just the scale of the projects he's worked on or the technical complexity behind them. It's the consistent theme of preparation. John's career has been built on staying curious, asking better questions, and being willing to adapt as the world changes. Water plays a part in so much of our lives, whether it's a river that overtops its banks, or a city struggling to keep pace with new realities. The consequences of our decisions show up eventually. John's career is a reminder that thoughtful, long-term work, often done quietly and out of the spotlight, makes a real difference. If there's a takeaway from this episode, it's that resilience isn't built overnight. It's shaped over decades by people who are willing to learn and collaborate and plan for future problems that they may never fully see. That's it for this episode of AE Live. I look forward to you joining me in the next one.
A-Live, we're going to innovate. A-Live, going to entertain and educate. A-Live, got a topic here to elevate. A-Live.